What's the most distant star you can see with the naked eye?
Ooh, that's an interesting question. Because I can answer that two ways. So one of them is the most distant thing you can see with the naked eye is our nearest red-blooded galaxy, the Andromeda Galaxy. And for the longest while, until the early 1920s, it was called the Andromeda Nebula because it was just this fuzzy thing in the night sky among the stars that trace out the constellation Andromeda. So we named it after Andromeda. And it was just a nebula, fuzzy thing. And then with better and better telescopes, wait a minute, this thing is composed of stars. Wait a minute, this thing is far away. Wait a minute, this is an entire other galaxy. It's not just a fuzzy thing in the Milky Way, it's another Milky Way. Well, how far away is it? It was not close, quote, close like these stars we see in the night sky. This is outside of our entire galaxy. The stars you see in the night sky are tens, hundreds, a few, or thousands of light years away. The Andromeda Galaxy is 2 million light years away. And you can see that with the naked eye.
In 1989, if you had a fax machine, you were badass. 1989 was the release date of Back to the Future Part 2, which took place in the year 2015. So you get to see how they imagine it. If you remember the movie, our lead character, Marty, irritates his bosses and he gets fired. Well, he's living in a home of the future. And any home in 1989 has one fax machine. That home has 4 fax machines because that's the home of the future.
That's my favorite request on stage. Can you give us a prediction for 2050?
I'll still do it.
I can barely give a prediction for 2030.
I'm gonna make 3 predictions. 1, we will have designer drugs. They'll analyze your genome, find drugs that will have no side effects for you. Why do we have to be a statistic in the reported side effects? You know, I'm not very side effect prone, so I generally ignore that, but many people are. So figure that out, medical community, so that there are no side effects. Have the medicine do only what it's supposed to do. Don't make it make you throw up or give you diarrhea or depressive thoughts or rashes. Fix that. Okay, that's 1. 2, I think in the not too distant future, all cars on the road will be self-driving electric. And you say, no, that can't be. No, because we went from horses to cars in 10 years. I'm just talking about going from cars to another kind of car. That can surely be less time than going from horses to cars. Self-driving, but you know, you start that, only self-driving cars in the HOV lane. Then these cars know where all the other cars are. If you want to change lanes, it tells the other car, I'm changing lanes now. They part, it changes lanes. And they can even text and drive at the same time with no loss of their acuity on the road because they're freaking electric computers. And they can drive 120 miles an hour with 2 cars distance between them because there's not going to be something they don't anticipate. And so once you see that, cutting down your travel time, I think it's going to go quickly. And but you're a car enthusiast. What do? I'd like my classic car. There'll be car parks for you to drive them. Is that any different from people who like riding horses and you go to the stables and ride horses? It's quaint, a quaint memory of a bucolic past. So you've got your Ferrari, whatever, you park it at the car park, you'll take an electric car to get there and you can do your thing as people who ride horses. So I see that happening. Last thing, I'd like to see space. People ask, where should we go next in space? All of space. Why does it have to be a next destination? When we built the interstate system, which to the tune of $100 billion, by the way, about the same as going to the moon, what drove that? Well, war drove that. What's the other name for the interstate system? The Eisenhower Internet System. He went to Europe in the Second World War, saw the Autobahn survive under rain and snow and tanks could roll over without it falling off the side of the road. He says, I want that in my country as a defense project. And so the initial monies for that all came from the defense. Were informed by our posture as a country that didn't want to get invaded and wanted to keep our military ready and you may know, the interstate system doesn't go over mountains, it goes through them. And after every distance, there's a certain stretch that is straight so that you can land an airplane on it if you had to. It is to military specs. That's how that money got dislodged. So I'm saying, when you build the interstate, you don't build, let's just go from New York to LA. No, give people choices. So you'd send the interstate everywhere, let people's creativity take them to wherever they want to start whatever businesses they want or have whatever free life they want to lead in a country that we still think is free. And so when I think of space, I think of not a rocket to go here or there, get a warehouse of sort of strap-on boosters, and I say, I want to do science on the backside of this comet that's coming through. We need these 3 boosters and this rocket, and we'll schedule the launch in 3 months. Think about that. Then the entire solar system becomes our backyard. And it's not this other place. It is we'll have a relationship with it. And yeah, let's mine some asteroids. We have wars on Earth over the limited access to resources that are plentiful in the universe, in our own backyard. The future of space is one where an entire category of warfare will be rendered obsolete because access to resources will be unlimited. Category of war would be gone forever. If the entire solar system had lanes that you would take and you decided where you wanted to go, and it wasn't a single national destination.
What is the Andromeda paradox?
Well, the Andromeda paradox is the fact that if you and I are looking at Andromeda 2.5 million light years away, then what happens is, suppose you're sitting in your chair and I'm running by. And at the second I run by you, we both look up at Andromeda. Because I'm moving and you're stationary, we're going to see events that are days apart, even though we're in the same location looking at the same time.
How can that
and
be?
you think that relativity. And you think that the
Don't just
light
say relativity and keep talking.
How far,
know, right?
wait, in this scenario, how far away from me are you when you're running by
You're in the same
me?
place.
We're in the same place, essentially.
So
I've
you're
never-
like literally
I've
running
never
here.
heard of this paradox.
And you look
right,
up,
it's a little known paradox,
and the
right?
thing
Yeah.
that you see and I see are days apart.
Days apart.
Because of our physical perspective on
Well,
that?
here's what you would think. You would think the light is arriving right now. We should all be receiving this light, but that's not how it works. Motion changes the perception of time. So how do you define what now is? So we
Even
don't
though
even
you're in the
understand
same
time.
place.
Even though you're in the same place, yeah.
While we're sitting here, I'm here, you're running by,
Yeah.
we look up at Andromeda at the same time,
Yep,
and we're
from the
seeing
same
something
location.
From the same
days
location.
from the same
Yep.
location,
Yep.
essentially. We're seeing things days apart.
Days apart.
And
Yeah.
that leads to the idea of what is now, and your now and my now are two different
There's no
nows.
now.
There is no now.
No, there is
on-
now. There's always now.
There's
There
an
has
illusion
to
of
be.
now because we're so close together and we're so small. The speed of light makes it feel like we have a now, right? But now doesn't really exist on larger scales. There's no such thing.
Do you know the pyramids in Egypt? They stopped building pyramids. I don't know if they ran out of pharaohs to build pyramids to, or they ran out of money. One day they stopped. Do you know the pyramid, the top of the tallest pyramid? Do you know what year we built something taller than that pyramid? After that pyramid was built? It was in the Paris Expo. The Eiffel Tower was the first object we ever built as a species taller than the pyramids. So just because you're doing something in one period of time doesn't mean it will continue forever. In fact, one of my great fears is that you end up taking it for granted.
I have a sample of aerogel in this office.
Really?
Yes.
I have never touched a sample of
You've
aerogel
never touched
in my
aerogel?
whole life.
Really?
Always wanted
This
to.
will be a first for Adam's Average.
It'll be a first for everybody. What the hell is aerogel?
Aerogel is the most ghost-like solid substance ever spun.
And it's like 99.9% air, right?
Yes, higher than that.
Oh my
Okay.
gosh.
So here it is.
Oh my goodness, look at that.
I said it's like a ghost.
It does look like a ghost.
Okay.
You brought a Tesseract
Oh
out.
my-
Hang on.
No
Hang on.
way.
Way. Okay. Look at that.
Oh my. Okay, that is one of the coolest things I've
It is
ever
like
seen.
ghost.
My
It
is.
It's actually solid. Right? It's not flexible.
Right.
It's very brittle.
It is science cotton candy.
Don't eat it, Chuck. Come here. Ready?
Wow.
That is aerogel.
Look at that.
That's. Oh my God. I can feel that it's.
You can pick it up. I trust you. It's like a ghost.
Look at that.
It might be the lowest density solid stuff ever. And it's used for NASA. And the aerogel has many applications. One of the ones that we care most about is you put that on a spacecraft, on a space probe, and as it flies through a comet's tail, particles of the comet enter the gel and it slowly stops it so that it's intact by the time you bring it back and then analyze it. It also has highly insulating properties. It's like one of the most insulating things ever known. And the way they make it, they have some polymer chain that they spin up, and it's this solid thing, but then they evaporate all the liquid. And what's left are the molecules that flesh out the volume that the liquid once occupied.
If I had hair on my neck, it would be standing on edge as I see the depth to which he was connected to the operations of nature. There is no doubt about it. The man discovered the laws of gravity by sitting there. Okay, it's rumored that he sat under the apple tree, but what is certain is that he knew in the same field of view, he saw an apple drop and the moon in orbit around the earth. Okay, he sees the two of them. One is falling to the ground and the other is like up there in space. He connects the two and suggests that the same force of gravity is operating on both of them. They're both falling towards Earth. He hypothesizes, well, how's that possible? Because I can drop this camera on the ground, they would fall, okay? But if it's in orbit, it's not falling. But it is falling. It is. If you're in orbit, you are falling towards Earth. He suggested, suppose you had a hill and you sort of fire a cannonball. Not very fast, it would just sort of kind of fall, right? Fire it a little faster. It goes farther before it hits the ground, doesn't it? Even faster, it'll go even farther. Now, wait a minute, Earth is curved. So if you keep this up, this thing is coming around the backside of the Earth. So he asked himself, there must be a speed sufficiently high so that that cannonball comes right back to the cannon. And all you have to do at that point is duck. And the cannonball ought to just slide on by and stay in orbit. The fact is the cannonball is falling every moment it's there. The difference is it's going sideways so fast that the amount that it has fallen is the same amount that the Earth's surface has curved away from it. That is the speed that gets you orbit. He figures this out. And that's why the moon is behaving the same way the apple is. The apple just doesn't happen to have sideways motion to bring it someplace other than right below. It's 1900. There's the fear of the great manure catastrophe. In Manhattan, which is not a large place, and you access it by bridges and tunnels, it's an island, there were horses, and horses do what they do. You feed them, they poop. The poop goes in the street. The horse, you don't take it to the horse bathroom, it's in the street. And the people's whole job was to clean up the manure. Now what do you do with it? You bring it to another place and it makes a pile. Then somebody else comes in with multiple horse-drawn carriages to haul the manure out of the island, okay? But those horses that are hauling the manure, they are pooping. Okay, so if you run the arithmetic on this, people imagine the manure catastrophe. And it attracted flies. There were no indoor supermarkets back then, at least in the inner cities. Most of food was sold by street carts. Your fish, your fruit, all of this was street carts. So the flies were everywhere. And so there was a lot of visioneering discussion about what to do about the horse poop or the flies. So they said, let's put something in the feed so that when it comes out as poop, the flies will not be attracted to it. Because that was one of the health issues. How do you get rid of the flies if you're not going to get rid of the poop? Then another one was, what can we feed the horse to reduce the amount of poop that comes out the other side? The actual solution was the car. Do you know that planet-wide greenhouse effect was first discovered on Venus? Venus has a really bad greenhouse effect. It's 900 degrees Fahrenheit on Venus. And I did the math. Venus saw it, you could take a 16-inch pepperoni pizza, put it on the windowsill, and it will cook in 9 seconds, okay? That's hot. We discovered plutonium in 1930. It is weaponized, turned into a bomb, and deployed 15 years later. That is the pace of what's going on at the time. The two bombs was a uranium bomb and a plutonium bomb. We knew uranium would work. We were not sure about plutonium. It was new boy on the block. And so that's what was tested at, as famously now portrayed in the film Oppenheimer. They tested the plutonium bomb, not the uranium bomb. That's the one that then was dropped on Nagasaki. Point is, between 1930 and 1960, we cracked the atom, weaponized the atom, break the sound barrier, go into space. Oh my gosh, is there anything about 1960 that would be recognizable to anyone from 1930? I think not. Those that say, well, we're spending, these people, okay? And so how much do you think NASA's getting? Here's your tax dollar, pull out $1, here's your tax dollar. How much are they getting? Okay? And here we go. Got my dollar. Oops, that's a 5. Wait a minute. Oops, that's another 5. There we go. Dollar. Tax dollar. How much? Here's your tax dollar. Is it 10 cents, 20 cents, 30 cents? How much is NASA getting? It is getting 1/2 of 1 penny of this tax dollar. 1/200th. That's not even, you're not even in the ink yet. Here, you're in the edge. That pays for the rovers, the space station, the space shuttles, the Hubble telescope, all the NASA centers, NASA headquarters, all of that. And I ask you, how much is the universe worth to you?